In this section, we're going to take another look at types of equations that you should be familiar with how to solve these equations, but let's go over it again. These are polynomials that really we have to kind of consider moving all non-zero terms to one side, and therefore we get a zero term on one side of the equation, and then we're going to apply our properties of zero product properties, and we're going to solve them. So basically what we've got to know how to do with these equations is we have to know how to factor, and you need to be able to do some factoring pretty quickly. So I'm going to go over these pretty fast, go through them kind of quickly. And if you're shaky on your factoring methods, then you really do need to get some help and get good at them quickly, because you're going to need these for the rest of the class, okay? So first I've got a binomial, two terms on one side, one term on the other. Let's move them all to the same side. We'll say that's 6x cubed, and I have a squared term. Now that would be the one next that I would want to put. It would be the next order of degree. So I'm going to subtract 4x from both sides. So over here it's going to be a negative 4x squared. And then I've got a negative 16x, and that's all equal to 0. So I moved the 4x squared to the other side, and I set them in order at the same time. And that's something I have to do, is have them in descending order. The exponents have to be in descending order. So the next thing I want to do is look for a GCF, and I see one. I mean, all of these are even, so you know you've got a 2 that can be factored out, but I've also got x in each of them. So I'm going to factor out 2x. I'm going to have a trinomial left, equal to 0, of course. 6 divided by 2 gave me my 3. X cubed divided by x gave me x squared. So I'm going to say minus 4 divided by 2 is 2. X squared divided by x is x. I'm going through this quickly because you should be able to do this pretty well by now. And then we're going to say a negative 16x divided by 2 is going to give us a negative 8. And of course, x divided by x gives us 1. So that one's gone. All right, there's my trinomial that I have to be able to factor, and my GCF of 2x. So now I work on my trinomial. I'm going to set one of each sign because of that second operation, and I'm going to go ahead and say, well, I've got to have an x in the first terms of each of them. And this time I'm going to look at my diamond method because it's the simplest one for me to demonstrate with. I look and I say 3 times negative 8 gives me a negative 24. The b term coefficient is a negative 2. If I come out and look at my factors, I'm going to put a coefficient of 3 in front of x, and I make one of them a positive, one of them negative, and there's how I'm going to find my factors. I need factors of negative 24 that will subtract really from each other to give me a negative 2 is what I need. So I'm thinking negative 24, I know the factors fairly well. I know 8 and 3, but they don't have a difference of 2, but 6 and 4 does. So 6 and 4 will work for me. I need a negative 2, so I need the bigger one to be negative. And then I look at reducing these. Well, 3x plus 4 does not reduce, so that's one of my factors. And then 3x minus 6, I can divide both of those by 3. I end up with 1x, or x, minus 2. So that's my other factor. And I never do this without foiling to check, so I go 3x times x is 3x squared, 4 times negative 2 is negative 8. Inside gives me 4x, outside negative 6x. When I combine those, I would get a negative 2x. So I have my factors right. Now I set each factor equal to 0, and because of the zero product property, I am solving, and I have a potential of 3 solutions. 2x is equal to 0, 3x plus 4 equals 0, and x minus 2 is equal to 0. Because you can see from the equation, if any of those 3 factors was 0, we would have a true statement. Both sides would be 0. I'm going to divide this one by 2. It's okay for me to divide 0 by something, so I say that's really 0. And then I have to move that 4 to the other side. It becomes negative, and I divide it by 3. And now I've got to move my negative 2, and it becomes positive. So I have 3 solutions. I have 0, negative 4/3, and 2. Okay, let's take a look at another one. This one says 16x to the 4th is equal to 49x squared. Well, because the way we're working, we want to get everything on one side of the equation and set it to 0. So My biggest exponent's over here on the left. I'll subtract that 49x squared and get it over there. I'm going to say this becomes 16x to the fourth minus 49x squared. And then I can factor out equals 0, right? I can factor out a GCF of x squared, can't I? Can I get anything else? Well, factors of 16, 1, 16, 4 don't fit with factors of 49. So I'm going to be able to factor out x squared. And I'm going to have left, once I do that, 16x squared minus 49, which I recognize as two perfect squares. 16 is a perfect square, x squared is a perfect square, 49 is a perfect square. And since it's a difference, what I have is a difference of two squares. You should remember that's the easiest factoring that we do. We have one of each sign. We take the square root of the first term, which would be square root of 16, for square root of x squared, and we put it in first positions. And then we take the square root of the second term, square root of 49, and there. That's my factors. So I've really got this thing factored. I'm going to say x squared, therefore, is equal to 0. And I've got 4x plus 7 equals 0. And I've got 4x minus 7 equal to 0. Okay, square root, if I take the square root of this, I'm taking x is equal to plus or minus 0, right, which is just 0. If I do this one, I have to say 4x is equal to a negative 7 and divide both sides by 4, so I get a negative 7/4. And when I do the third one, I get 4x is equal to a positive 7. When I divide both sides by 4, I get 4x is equal to a positive 7/4. So there are my three solutions: 0, negative 7/4, and positive 7/4. Let's look at a third problem that requires us to do a different type of factoring. You notice that there are 4 terms. It's already said equal to 0, but I've got 4 terms, and that says that I'm going to be doing this one by grouping them. Now, because the middle operation is negative, I'm going to have to include it in the second group. I'll show you right here if I can, and I would put a plus in between them just to show that I'm not going to be turning this into a FOIL problem, okay? So what do I have now? I have a GCF with this first group of x squared. When I factor out the x squared, what's left is x plus 1. Now I'm going to factor out for this second group a GCF of negative 4. So I say plus a negative, well, that's just minus 4, isn't it? And when I factor out the negative 4, it changes the signs of both terms. And I have x plus 1. Once again, still equal to 0. Then I note, as with factoring all grouping problems, if I don't have matching binomials, it didn't work. But this time it does. I have x plus 1. And then I have times whatever's left over. What was left over? X squared minus 4, right? So that's my second binomial. And I'm not finished because this is a difference of two squares. Well, once again, easiest factoring that we do. Set up my 2 binomials, one of each sign, square root of the first term, square root of the second term. I'm done. I just have to make sure that I don't have another difference of two squares because it can happen to me. Now I've got 3 answers here. X plus 1 is equal to 0. X plus 2 equals 0, and x minus 2 equals 0. Fairly easy to solve. We just subtract 1 from both sides, and we get x is equal to negative 1. Here I'm going to subtract 2 from both sides, and x is a negative 2. And on the third one, I will add 2 to both sides, so x becomes a positive 2. My solutions, negative 1, negative 2, and positive 2. Number 4 looks like it's got 4 terms here, but they're all on both sides of the equation. And that's the first thing I want to fix. I want to get them all to the same side. I'm going to move them to the side that has the highest exponent. There's an x to the 5th, an x to the 4th. Let's subtract these 2 and get them to go to the other side. So when we do that, let's see what we'll have. I'll put it over here. I'll have 10x to the 5th plus 15x to the 4th. Now I had to subtract that 2 x cubed, and I had to subtract the 3x squared. Once again, when I subtracted them both, there's nothing left on that other side, so it's a 0. Now, I do know I have a GCF in this thing of x squared. All of them have an x squared in them. So I can start this thing off by just factoring out the x squared, can't I? Let's do it, because even when we have 4 terms, we're probably going to end up with grouping. Simplifying it by factoring out a GCF first is always a good idea. So I'm going to factor out my x squared here, and I have x squared times, and that would be 10 x to the power of 3, wouldn't it? Plus 15 x squared minus 2x, and this is going to be minus 3. Factored out all of the x's there. Now, once I've got this, I think I've got a grouping problem, don't I? Once again, it has a negative, but I'll go ahead and group it like this and put a plus just to show that we're not turning it into multiplication. And keeping my GCF of x squared out here, I'm going to look for a GCF to add to it out here. I'm going to say, what is my GCF on this one? Well, I'm going to say I have a GCF of this group could be a 5x squared, right? Now, the one thing I want to do is kind of keep them separated. I've already factored out the GCF, so I'm going to put these in big brackets just to show we're working this sort of as a separate problem until we get to the end when we'll combine our factors, okay? So inside here, I found that GCF of 5x squared for the first group, and what I have left over is 2x, and it's plus 3 when I factored it out. The second group doesn't seem to have a GCF, but they're both negative, and I know I'm going to always factor out the negative when the first term is negative. So when I factor out that negative, I have 2x plus 3, change the signs, which is exactly what I wanted. So let's see what this looks like. X squared, and then inside my groups, I'm going to have, let's go ahead and write this first one down, 2x plus 3 times whatever was left over, right? 5x squared minus 1, and I'll go ahead with brackets and finish that as equal to 0. So what do I have? Let's write it down a little clearer. X squared times 2x plus 3, I'm getting rid of one set of brackets, times 5x squared minus 1. It's a shame that's not a difference of 2 squares, but it's not, is it? So because of that 5, if it had been 4x squared, I could have factored a difference of 2 squares, but I can't. So let's see what I can do with it. I can set x squared equals 0. I can set 2x plus 3 equals 0. And then I can set the hard one, 5x squared minus 1 equals 0. Now let me finish this out. If I take the square root of both sides, x is 0, right? I'm going to subtract 3 from both sides and divide by 2. Now over here, I'm going to go ahead and say, okay, let's get rid of this negative 1. We'll say 5x squared is equal to 1. We'll divide everything by 5 then. Then I have x squared is equal to 1 over 5, don't I? Now, what I have here is I'm going to take the square root of x squared, right? Take the square root of x squared gives me x. And that means I have to make this plus or minus the square root of 1 over 5. Okay, so that's 2 solutions instead of 1, a little unexpected. But am I finished? Well, I've got a radical in the denominator, so I'm not finished. This is going to have to be multiplied times something and under the radical, right? So that I can get rid of that 5. If I want a perfect square, I would multiply it times 5 over 5. That's okay for me to do that. What happens then? It becomes x is equal to plus or minus, and I'll go ahead and separate these out. That would be 1 times 5. And this would be 5 times 5. Whoops, square root of 25, right? Which is plus or minus the square root of 5 over 5. That's allowed. Okay, I can have radical in the numerator, but not in the denominator. So I ended up with 4 answers. 0, negative 3/2, and a positive square root of 5 over 5, and a negative square root of 5 over 5. Now let's kind of change gears and look at another type of equation that we need to be able to solve. And this one is really called a radical equation. Now, a radical equation has the variable, our unknown, our x, is underneath a root. It's a cube root or a square root or any kind of root. So what we are going to have to do is raise one side of our equation to, or both sides actually, to the power of that radical. And when we do that, you have to note this. We might come up with something called extraneous solutions, extraneous roots. Therefore, before we've been saying, check your answers, check your answers. This time you have to check your answers. Because of these extraneous solutions, you might come up with a perfectly logical answer. It worked, but when you plug it back in, it does not work. So you must check your answers for these types of equations. Keep in mind, if the variable is under a radical, you're going to have to check the solutions when you plug it back in. Now, the first thing we're going to do for this first problem is we're going to isolate the radical. We want to get it on one side. We're going to have to get rid of the -3, so we will have square root of 6x plus 5, and that's going to equal a +3. I added 3 to both sides, didn't I? Now I can raise both sides of this equation to the power of the radical. In other words, it's a square root, so I can square both sides, right? When I square, keep in mind, I won't write this always, when I square a square root, I basically get rid of the radical sign. And that way I have to square this side, and it ends up being 9, right? Okay, now I can solve this. This is not hard. I go subtract 5 from both sides, so I have 6x is equal to 4. And when I divide by 6, I come up with 4 over 6, which I know to reduce, right, to 2 over 3. Now, I do have to check it. And it looks like a fraction, which I don't like, but sometimes they're not hard when you plug them back into radicals to check them. Let's do it like this. 6 times x, well, I'm going to say 6 over 1 times x because it's a fraction, 2 over 3, okay? And it would be plus 5, still under the radical sign, and then that's -3 equals 0. Okay, so cross-reduce before you multiply. And really what we're saying is this is going to be 2 times 2, isn't it? Which is going to be 4 plus 5, still under the radical, -3 is equal to 0. And 4 plus 5 is 9. And I know the square root of 9 is 3. So what happened at that point, 3 minus 3 is equal to 0, my solution worked. Let's do another one. This one is sort of the same thing. I'm going to say get rid of this -6 by add 6 to both sides. So I'll come down here and I'll say I've got square root of 5x minus 8. And that's equal to 2 plus 6, right, which is 8. And I'm going to square both sides. I'll go ahead and write it down so I can remember what I'm doing. Squaring both sides. I've got 5x minus 8. And it's equal to 64, isn't it? Now, let's get rid of the 8. We'll add it to both sides, or the -8. Add 8 and 64, I end up with 72. Is that right? I think so. And then I divide both sides by 5, and I have 72 divided by 5. You can check this in your calculator to see if it would reduce. But basically, it would have to have a factor of 5, which there are only 2, 1 and 5, and neither one of those will, 5 won't divide into 72, so it's at its slowest form. Let's check it. Once again, we've got these fractions that we don't like, but we know how to deal with. We write the whole number as a fraction, multiply times the fraction, which looks like it's going to help us out by cross-reducing, doesn't it? And I'm going to say minus 8, and we'll be careful to keep all of that under the radical. Minus 6 is equal to 2. So cross-reducing those, they both turn into 1s. What do I have? Under this radical, I've got 72 minus 8. Minus 6 is equal to 2. Well, 72 minus 8, I did that before, didn't I? 72 minus 8 was 64. And if I say, take that minus 6. I'll keep it there. Okay, so what's the square root of 64? Well, that would be 8. Minus 6 is equal to 2 is what my statement says. It's right, so my solution was a good one. Now, these problems are about to get a little more complicated, so just hang on and remember your basic algebra and just keep doing the next step. You don't have to see the solution to a problem when you start working it. You just have to see the next step. And that's how you're going to get through a lot of things in college algebra. So first thing I see is x is here, and I've got really one term which has a radical in it, but my unknown, my variable, is under the radical, and I've got a -9 over there. I'm going to isolate the radical term first. I'm going to get rid of the -9. So I'm going to say x plus 9 is equal to 3 times the square root of x plus 13. Now I've got the radical term isolated, but it's got a coefficient. If I want to get rid of that, I'll divide this side by 3, and I'll divide this side by 3. Okay, now remember what this is going to do for me. I isolated the radical, and then I simplified it down to where it had a coefficient of 1. That's what I want. This is really 1x over 3, which is, think about separating these terms, 1/3 x. This is plus, right, 9 over 3, which is just the whole number 3. So I've got 1/3 x plus 3 is equal to the square root of x plus 13. Now I have the radical all on one side, so I can eliminate my radical by squaring it, right? So if I square this side and I square this side, the right side's easy. When I square a square root, I simply get rid of the radical sign. But on this side, I've got a binomial that I'm squaring. And remember the rules to squaring a binomial, because you don't really have to want to write it out twice and do the FOIL every time you do it. What you want to do is say, I'm going to square the first term. I'm going to multiply these two terms together, and then I'm going to double them. And then I'm going to square the second term. Okay? Now let's try that. I'm going to square the first term. I'm going to say 1/3 times 1/3. Well, that's 1 over 9. X times x, x squared. I squared the first term. I'm going to multiply these two terms together. When I say 1/3 times 3, I end up with 1. I end up with 3 over 3, which is 1. So I said I end up with 1x. Well, if I double that, it's 2x. And then I'm going to say 3 times 3. Well, that's 9. Now, you can write this out and go through the steps, but you got to get quick at it. So you're going to want to practice that until you get in your head. Square the first term, multiply the two together, and double, and square the second term, okay? Until you have that right, because it's a perfect square trinomial is what it is. Now, if I had a minus here, we would, of course, had a negative as the first sign, okay? First operation. Now let's see if I can do something that will get my terms together here. And basically, that's not too hard. I'm going to put everything on one side and have 0 over here. So I'm going to subtract x. Well, I'm going to put minus 1x just so I can show you what I'm doing. And I'm going to subtract 13, which is going to be subtracted from that 9. Okay? Makes it 0 is equal to, well, let's figure out what we got here. I've got 1 over 9, x squared. And 2x minus 1x is just 1x, right? So I've got plus x. And I've got 9 minus 13 gives me a -4. Okay, so I've simplified it. It's all equal to 0. I do recognize how to solve an equation that's like this, but every equation that has a fraction in it, what's your first step? Clear the fractions by multiplying each term by that LCD. I've only got one fraction. So LCD here is equal to 9. So I'm going to say multiply everything in this equation times 9, okay? Now when I multiply 1 over 9 times 9, it's 9 over 9, which is 1. So I just get x squared. When I multiply 9 times 1x, I get 9x. When I multiply 9 times -4, I get -36. And when I multiply 9 times 0, I have 0. I got rid of my fractions. So much happier with this, solving it, than that, okay? So all I have to do now is say, does it factor? Okay. Negative says one of each sign. I've got an x as the first term. I'm looking for, this is a simple polynomial, a simple trinomial, so I can just kind of shortcut it, say, I'm looking for factors of -36 that will subtract to give me 9. When I can think through the factors of 36 pretty fast, 1 and 36 won't work, will it? And 2 and 18 won't work. 3 and 12 would be the next thing I would try, and you can do this on your calculator, just working up with 36 divided by 1, divided by 2, divided by 3, but you should be able to do it in your head too. So 36, I found 3 and 12, right? Has to be a positive 9, so the bigger one has to be positive. But never do this without foiling to check. X times x is x squared. 12 times negative 3 is negative 36. Inside, 12x minus 3x gives me 9x. So I'm good. Now, simple. X plus 12 is one of my factors. It would be set to 0. X minus 3 is another one, and it would be set to 0. And when I solve for that, I have a solution of negative 12 and positive 3. And yes, both of these must be plugged back into the original equation and checked because we have squared both sides of this thing. We could have extraneous solutions. So back with the negative 12. Negative 12 for x is equal to 3 times the square root of negative 12. What was the next one? Plus 13, right? And it is then minus 9. Okay, now plug it in correctly. I've got, I think so, negative 12 over here is equal to 3 times, well, negative 12 plus 13 is the square root of 1, isn't it? Minus 9. Isn't that just square root of 1 is just 1? So what do I have? I have negative 12 is equal to 3 minus 9. Well, 3 minus 9 is negative 6. So that one did not work. Negative 12 is not a good solution, okay? It turned out that that was an extraneous solution. Well, let's see if the other one works. We'll try 3. So I've got 3 is equal to 3 times the square root of 3 plus 13, and then minus 9, right? So 3 is equal to 3 times the square root, what, of 16 minus 9? Well, that's 3 is equal to 3 times 4 minus 9. And 3 times 4, of course, is 12. Minus 9, at that point, I can say, yeah, 12 minus 9 is 3. This is a good solution. My only solution that checked out was x is equal to 3. Let's try another one of these. It's already sort of simplified for me. This one's not too hard. I'm just going to square both sides. And when I square this one with the radical, I'll go ahead and write this down. I'm squaring it also, right? I get 5x minus 1. I got rid of my radical. And remember, I'm squaring that entire term, which is negative. So I square the negative, which turns it positive, right? Negative times negative. So then let's go ahead and say 5x, therefore, is equal to 16 plus 1, which is 17. And x would equal 17 divided by 5. And now let's check it. My radical over here is the square root of 5 over 1 times 17 over 5. And then it's minus 1. And then that's supposed to be equal to a negative 4. Okay. So when I did this and I cross-reduce, what I really have is the square root of 17 minus 1 equals negative 4. And that's the square root of 16 equals a negative 4. And remember, that square root is 4, isn't it? Which is not negative. So this one, the one solution I found didn't work. So we say our solution, we don't have a solution. This one doesn't have a solution. Or you could say it had the null set. Okay, now this problem, number 5, they're getting a little trickier for us because we've got the variable is under the radical, but there's 2 of them. So I'm going to put 1 on each side of the equation and see if I can't just square both sides of the equation to get rid of both of them at the same time. That's a good strategy for me to use. So I'll have this one is the square root of 2x minus 1. And when I subtract from both sides this square root of x plus 2, I end up with a positive x square root of x plus 2 over here. Now, let's use my squaring both sides, right, to get rid of the radical. So I'll square this side. Square this side, and I have 2x minus 1 is equal to x plus 2. That was a pretty good strategy for me to use. It's simple now. Subtract x from both sides, and I end up with just 1x over here. Add 1 to both sides, and I end up with 2 plus 1 or 3. So x is 3. And when I check that, I end up with the square root of 2 times 3 minus 1. And that subtract then this radical, which is 3 plus 2, and that's equal to 0. Well, this is the square root of, that would be 6 minus 1, or 5. And this is 3 plus 2, or 5. So what I've got is square root of 5 minus the square root of 5 is 0. Anything minus itself, yeah, it's 0. That's checked out, didn't it? Now, let's see if we can do it again, but this time we've got a little bit of a complication. In number 6, we have more terms than just radicals, don't we? I have one on each side, but I've got also a 1 that is added to. Now, our problems are going to get a little more complicated. We're going to find ourselves sometimes going through the same step over again because it brings us back to another radical. But there's also a strategy where we find a radical on both sides of the equation that has a variable underneath, and all we have to do is therefore square both sides and get rid of our radicals. That's what this number 5 is leading us to. First, I have 2 terms, and then 0 on the other side of the equation. And if I can get the radicals to be 1 on each side, I can just go ahead and square both sides and I'll be done with my radicals. So let's do that. Let's say the square root of 2x minus 1, and I'm going to subtract this, add this second term to the other side, and when I add it, I end up with a positive x, a square root of x plus 2. So now what do? Well, now I just use my strategy to square the radicals, right, the square roots, and I end up with 2x minus 1 is equal to x plus 2, which is pretty simple to solve. I'll subtract x from both sides, and that ends up with 2x minus x being x. I'll add 1 to both sides. 2 plus 1 is 3, and x is equal to 3. Let's check it and see if it worked. It is the square root of 2 times 3 minus 1, and it would be subtract from that the square root of 3 plus 2, and we want to see if it's equal to 0. So really this is the square root of, that would be 6 minus 1, which is 5. And here's the square root of 3 plus 2, which is also 5. And what are they asking? Square root of 5 minus the square root of 5 is equal to 0. And it checks. X equals 3. 3 is our solution. Now that was simple because we just had a radical on each side. But what if there's another term added to it or subtracted? This one's not as easy. I have a radical on both sides. Both of them have variables, but I've got a 1 added to it. So I can do something else that I know how to do. I can square both sides just like I know I have to, and I will get rid of this radical. It will be x plus 2. Now on the other side, I'm going to have to FOIL. Remember foiling a binomial, it's perfect square trinomial type of problem. I'm going to say 1 times 1 is 1. I'm going to say 1 times square root of x minus 3 doubled will give me 2 square root of x minus 3's, won't it? And then I'm going to say square that square root, which gets rid of the radical. Okay, now much simpler here. I want to get this radical isolated. I want this term right here to be all by itself. So I need to get a 1 and a negative 3 away, but first let's look at our x's. I have an x over here, a positive x, and I have an x over the other side. And when you have the same term on both sides of an equation, basically they cancel each other out, don't they? So we can get rid of them. So now if I want to take and simplify my other terms, I have 2 is equal to, let's add these. I've got 1 minus 3, negative 2, plus 2 times the square root of x minus 3. Okay, add 2 to both sides. That gives me 4, doesn't it? It's equal to 2 times the square root of x minus 3. And now get rid of my coefficient by dividing by 2. When I divide by 2, I have square root of x minus 3, right? But I had to divide this side by 2 also, so I have 2. Now I can go back and do it again. Square both sides, right? I'm repeating the step that I know to do when I have isolated the radical term. So this gets rid of my radical. I have x minus 3. And on the right or left over here, I have 2 squared, which is 4. Well, a simple one this time to solve. Add 3 to both sides, and x is equal to 7. Now let's try it out. Checking this, the square root of 7 plus 2 is supposed to equal, or we're checking to see if it's equal to 1 plus the square root of 7 minus 3. Well, the square root of 7 plus 2 is the square root of 9. And we want to add that to this we want to add 1 to the square root of 7 minus 3, which is square root of 4. Square root of 9, that's 3. This is 1 plus square root of 4 is 2. So 3 is equal to 1 plus 2. So we have checked it and it works. Let's do one more rather complicated one. It's the same type of thing though. They've already sort of given us a head start here. They have taken, look what I did up here, I squared the radical. Well, they have already squared the radical, haven't they? And they've squared the other side. I had to do that step, didn't I? But they've already written it in for me. So when I square this side with the radical, basically I get rid of the radical. But this time I'm going to have to FOIL. So I'll say square root of x plus 1 times itself. Well, that will be squaring it, right? So it'll give me x plus 1. And then when I multiply the two terms together and double it, I'll have a negative 2 times the square root of x plus 1. And when I square negative 1, I have a positive 1. Okay, x on both sides, right? So let's go ahead and eliminate those. I have a negative 6 over here. I need to get everything on this right-hand side and leave my radical term alone. So I have a 1 plus 1. I have 2 minus 2 times the square root of x plus 1. There's no sense trying to do too many steps at once. We just mess up that way. Subtract 2 from both sides. And I say negative 6 minus 2, negative 8. Divide both sides by that coefficient, negative 2. Square root of x plus 1 is left, and I have a negative 8 divided by negative 2 gives me positive 4. And now I'm going to do it again. I have a radical over here. I can get rid of that square root by squaring it. I have to square both sides. So what do I have? X plus 1 is equal to 16. And when I subtract 1 from both sides, I have x is equal to 15. Let's check and see if that's the case. I end up with the square root of 15 plus 1 minus 1, and don't forget, all of that was squared, equal to the square root of 15 minus 6, and that was squared. Okay, this is, what's the square root? Well, this one is 16. What's the square root of 16? 4. Okay? And this one is 9. What's the square root of 9? It's 3. So what I have here is 4 minus 1 squared, which is 3 squared. And over here I already had 3 squared, didn't I? Which is really 9 is equal to 9. And I have my solution. Now don't forget, sometimes you just have to keep going. You have to try one thing and go to the next step and see where it takes you from there. And then say, oh, okay, well, I can now do this, which even though you did it once before in the problem, it is okay to do it twice.